Now, these are going to have, I actually am going to put stars by them. And we're going to do the zeros of R4. And I'm just going to put square root of 3. And I'm going to put a comma there, and then we need to talk about it because we've mentioned this before. Irrational / imaginary zeros, solutions, ever how you work at them, always come in pairs. Now, do you remember why we said that? Because when you do that, I think I've got some notebook paper right here. Remember the quadratic formula, x equals, and that's going to give you the zeros. It's going to give you the solutions if you're solving a quadratic. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, there it is right there, plus or minus. If this is negative, you're going to get 2 imaginary. If this is like 17, you're going to get 2 irrational. So you will always have 2 solutions from irrational or imaginary zeros. Now, sometimes they'll give them to you, and sometimes they don't. So sometimes they might say 4 positive square root of 3, negative square root of 3. But you have to know that if they only give you 2, and one of them is irrational, or if they only give you 1, if you only have 1 irrational or 1 imaginary, there's always going to be another one that goes with it. Sometimes they put it there, sometimes they don't. So you have to be careful that even though you look at this and you think it's going to be quadratic, because here's the problem. If you only use this one as your solution, you're going to have square root of 3 in your polynomial function, and we don't. We know that every time we write our functions, we have integers, coefficients of 1, negative 29, 100, 1, negative 2, negative 9, 18. We don't have square roots, and we don't have i's in those. So we're going to, so whether they put it there or not, you've got to know that it's there. If you have an irrational, you got to have an imaginary one. So my f of x is equal to x minus 4 times x minus square root of 3 times x plus the square root of 3. And you have to have the pair of those because that's the only way you're going to have the be able to write this with integers. Remember when we did lesson, let me see, yeah, over here on lesson 39, when we wrote the exact solutions, and they were, like in this case, they were irrational. But where did those come from? They came from a nice little polynomial here that we could multiply by and get this. I mean, I could have given you these 3. If I'd only given you one of them, we knew the minus one had to come with it. So same thing with i's. Now, these are a little messier than the ones we're doing, but it's the same concept. So I know that I will have 3 zeros if anything I'm given is irrational or imaginary. So in this case, I'm going to definitely distribute these two. You definitely want to get them together to get rid of that square root of 3. Now, where is it going to go? I'm going to leave my x minus 4, and I'm going to distribute it out, and I'm going to actually show it. So when I pull it out, I've got x squared. I've got plus x squared of 3 minus x squared of 3. I put my x at the front, just doesn't make it look like it's under the radical. And then I get minus the square root of 9. Well, but these add out. And so I no longer have radicals because we know that. We have x minus 4 times x squared minus square root of 9 is 3. Now, definitely integers. No irrational, no imaginary. Now, let's pull that out. And we get x to the third. And I'm going to actually go ahead and do the inside next because that's my x squared, and I'll have it in that descending x cubed x squared order. And then I'll do my minus 3x, and then I'll do my plus 12 because you do want it 3, 2, 1, none. And if I had done it in the order that I had it, I'd had to switch these two around. So to me, it was easier to do that. If you graph that, it's going to cross the x-axis at 4, and then at square root of 3, which is like 1.7 something, I think. It's 1 point something. It's going to be, would be where the two places where that your graph would have crossed. Now, number 6, let's do some with some eyes. Let's do zeros. Okay, let's do -1. Let's do 2. And let's do 5i. Now, I'm going to automatically put me another blank and put -5i. Rational, irrational, imaginary, can't talk, always come in pairs. So even though it only looks like 3, I can't have a positive 5i if I don't have -5i. And notice we're not getting into the crazy 1 plus 5i over 7 or anything. We're doing pretty basic imaginary ones. So I've got f of x is equal to x plus 1 times x minus 2, x minus 5i, and x plus 5i. Now, I think we did, when we talked about operations with imaginary numbers, we actually did some fooling with them. Now, I would definitely put those two together and definitely those two. So I've got x squared. And the irrational rational don't come that way. Like 4, just because you have 4 doesn't mean you're going to have -4. We know that from our graphs. So you can have individual rational ones, but you can't have individual imaginary or irrational. So I've got x squared. See, I've got plus 1x minus 2x, so I'll have minus x and then minus 2. And then over here, I'll have x squared minus, you can write it several different ways. Let's see, let's do the outside. Plus 5ix minus 5ix, and then minus 25i squared. So I've got x squared minus x minus 2. And then these are gone. And I have x squared. I squared, remember, is -1. So -25 times -21 is positive 25. Now, it's still a little messy. I'm going to have 6 terms like we did over in number 2. But it's not that painful. So I'm going to go, I think I'm going to come this way. So I'm going to do my x squared, x to the 4th, minus x cubed, minus 2x squared. I'm just distributing my x squared this way. And then plus 25x squared minus 25x minus 50. Now let's see if we can get everything organized. X to the 4th. Okay, now let's do our cubes. We've got it 1 cubed. So we got minus x cubed. We've got plus 23x squared minus 25x minus 50. So it actually wasn't that painful. Okay, let's do one more, and then I'll show you one. I don't remember if you have these in classwork. Number 7. Okay, let's do zeros of positive 4i and negative 6i. Now, I'm immediately going to put 2 more blanks. Imaginary come in pairs. What comes with positive 4i? Negative 4i. What goes with negative 6i? Positive 6i. Now, I'm going to match them up in pairs. So I'm going to write x minus 4i and x plus 4i. And then x plus 6i. And again, the order really doesn't matter, just as long as you get all of them as we're fooling it out. So these two are going to give me x squared. And I will go ahead and show it. A lot of you probably would see it, and I'd have plus 4ix minus 4ix minus 16i squared. See, those are going to add out. And if you can see that, that'll save you a step. And then this one, x squared minus 6ix plus 6ix minus 36i squared. So this one gives me x squared plus 16. And this one gives me x squared plus 36. Now when I pull that out, I will get, and if you're okay, I'm going to go ahead and get my final one. I've got x squared times x squared, x to the fourth. Then I'm going to have plus 16x squared and plus 36x squared, which will be positive 52x squared. And then 16 times 36 is positive 576. Now, if you have one, just a note here, if they say that you have zeros, you might see this on the ACT, they might say something like -3, comma, and then they might put 5 multiplicity 2. Now, what that means is you've got -3, and then this means, I tell you what, let's scoot that down one. This one gives you -3, and then this one gives you 5 twice. Now, I probably would just list 5 twice. So you'd have x plus 3, x minus 5, x minus 5. But sometimes you'll see that, so that means you have 5 twice if you happen to run up on that.